Yo, what's up guys? Welcome back. Patrick here, and in this video what we're going to do is go through these expressions here, these four expressions, and we're going to multiply each of them. So starting with this one, we got 3x to the 4 y to the 5 times negative 4x to the 3 y to the 2. So what I'm going to do is I'm actually going to multiply the numbers together. So 3 times negative 4 is negative 12. And then I'm going to multiply the x values together. So we'd have x to the 4 times x to the 3. Notice that if we're multiplying exponents that have the same base, we can just add those exponents. So that would be x to the 7. So that would be x to the 7, y to the 5 times y to the 2, add the exponents, y to the 7 there. So that's the final answer for number 1. Now number 2, same sort of thing. We're just going to be dealing with fractions now as the numbers. So notice that this one here, the number, the fraction is separated from the variables, but this one it's kind of together. But what we can do, I'm going to rewrite this first expression as is. We could take this expression, separate it. So we would end up with 5 over 6 x squared y to the 3, like that. And then we can, so I took this, separated it, and now we can do the same thing that we did up top. We can just multiply these two. So 3 over 5 times 5 over 6, 3 times 5, 15. 6 times 5 is 30. X times x squared, there's like imaginary ones there. So it's like x1 times x2, that would be x3. Add the exponents. Y1 times y3 would be y4. And then notice that this 15 over 30, that can simplify to 1 over 2. Right, so that's the final answer, and maybe a different format you could put it in is like that. So either this or that, both of those are the exact same thing. Next up is multiplying these two. So here we're going to have to use the distributive property. So we're going to have to take this expression, multiply it by this, multiply it by that, then multiply it by that as well. So starting with these two, negative 5 times 6 is negative 30. X to the 2 times x to the 2, that's x to the 4. Then y to the 3, notice there's no y expression here, so we would just leave that y to the 3 as is. Negative 5 times negative 4 is positive 20. And then notice we have like ones here. X to the 1 times x to the 2, that would be x to the 3. Y to the 3 times y to the 1, y to the 4. Then negative 5 times 8 is negative 40. Notice there's no x expression here, so we would leave it as x squared. And then y to the 3 times y to the 2 would give us y to the 5. You would add those exponents. So that there is the final answer for this when we expand everything. And then finally, number 4. Here what we're going to have to do is notice we're taking a binomial, multiplying it by another binomial. So we're going to have to FOIL this out, meaning that we got to multiply this and this together, this and that, and this and this, and then that and that. And then we have to simplify like terms. So 3xy times 2xy, that would give us what? 6x squared y squared. Right? There's like ones here. 3xy times positive 7 would give us 21xy. Negative 5 times 2xy would give us negative 10xy. And negative 5 times 7 would give us minus 35. Like that. And then from here, what we do is simplify any like terms. And where are the like terms? This and that. So 6x squared y squared. 21xy minus 10xy would give us 11xy minus 35. Notice that this and this are not like terms because the exponents are different. Right? We got x2, y2. Here we got x1, y1. But here the exponents were the same, x1, y1, x1, y1. So we can simplify, net out those leading coefficients. They netted out to 11. So you can't simplify this any further. So that is the final answer for number 4.